Hey, hi, Mohammed.
Hello, how are you
Uh,
doing?
all good. How are you?
I'm good, thank you. Thank you
So,
for.
and we are going to start in a minute. Okay. So, hi, good day, everyone. Welcome to TestMu Conference 2023. I hope everyone is doing great so far. I can already sense the enthusiasm in the room. My name is Jatin, working as an engineering lead at the Lambda Test. Now, joining us today in the session is Mohammed Aboullaite, who is working as senior backend engineer at Spotify. He's community catalyst and the open source contributor, and have an extensive hands-on experience in building and evolving distributed application at scale. Also, he's one of the Google experts in the cloud. And today, he's going to shine a spotlight on the topic as move fast, move things safely, which is the most hot topic in the industry. But before I hand over to Mohammed, a suggestion for all are the attendees. Sure, love, for the topic by using emojis, which you can find on your screen below. Also, at the end of the session, we would be taking questions, so feel free to add those questions in the Q&A sections. Guys, let's keep that momentum going as we delve into an exciting day of learning and the collaborations. Now, please join me in welcoming Mohammed. Mohammed, over to you.
Thank you very much. Thank you very much, Jatin, and to the whole team behind the conference. Really happy to be here with you. And Hi again, everyone. Again, super happy to be here with you. Where we're going to discuss in the next 40 minutes or so how we can move fast while building things in a safe manner. Now, I believe Jatin did a extensive introduction for me, so I'll be skipping the boring part and jumping directly into the fun, which is what I believe most of you are here for. As Jatin mentioned, we will be having question by the end of the session. I'll keep an eye on the chat. If you have any question that I can answer while in the session, I'll happy to do so. Otherwise, we will save some time in the end for an extensive Q&A session. Okay, let's start. And we all probably in this conference and this virtual room agree that the demand for speed and innovation is now everywhere. Um, Clients, customers, users no longer wants to wait for weeks or days to get their bug fixed, to get their new functionality shipped, to get their user experience improved. They want this bug fix, user experience improvement features as fast as possible. However, the enthusiasm for creating or speeding or evolving our product uh, tends to butts up most of the time with security, which tends to value what we call the status quo. And in some cases, the budget hunt to increase the velocity of our teams can introduce some challenges, especially from a security point of view, such as skipping processes, insufficient testing, unreliable testing as well, just trying to ship as fast as we can without spending the time on gauging the security and the testability and reliability of our application. And we all know a company that was bragging about how fast they were moving, how fast they were introducing things. However, they soon reached a roadblock because they didn't care about security much. And I like to say that security is pretty much like air. When it's there, nobody notices it. And the moment it's when it goes missing, everyone starts screaming. And that's what the DevSecOps movements try to fix, right? it tries to save a seat to everyone in the table. It tries to so DevOps is definitely desired, as I mentioned. The security is also required, because once the security is missing, the trust that you spent a lot of time building with your users is basically gone, which creates a lot of issues and a lot of problems to gain this confidence back. And this is what DevSecOps is trying to bring to the table. And by the way, I hate the name DevSecOps. I found, like, as Solomon Hykes, which is the founder of Docker, DevSecOps is basically DevOps being right. But for the sake of understanding, we'll be using it throughout this presentation, and the naming will be a discussion for later, maybe. As I mentioned before, DevSecOps tries to save a seat to everyone in the table. It tries to let the developers focus on the things that they do best, shipping new features, fixing bugs, improving the user experience, and so on and so forth. It tries to let the operation folks release and ship those artifacts as soon as they are released, and make them available to our widely user base. But it also tries to save a seat in the table for security folks, making sure that the artifact that we release, the things that we ship, the applications that we deploy facing the internet most of the time are secure and doesn't expose any vulnerability or any issue for our users. So you probably now have an idea of what we are going to talk about in the remaining of the presentation, and it's going to be the Formula One. So I'm not sure if the audience is familiar with Formula One. Please let me know in the comments. But Formula One basically is a motorsport. It's the fastest. Is the fastest motorsport in the world in terms of cars, and they drive at an insane speed, and they have a championship both for drivers and the team, and it's basically drive innovation in the car world and in the motor world, and a lot of innovation that happened into Formula One basically get introduced into our cars, namely a lot of things. And during the pandemic, we had a lot of time to between our hands, because we were basically quarantining, forced to stay in our homes. So I started watching the Formula One Drive to Survive documentary. It's basically it's not a documentary, but it's more of a reality show behind the scenes of the Formula One races, and it's called Drive to Survive. And while watching this series, this actually happened. So it was during the Bahrain Grand Prix in 2020. And Roma, which was a driver from the Haas team, did a bad maneuver and drove to the barrier directly at a lightning speed. He was driving around 300 kilometers from 300 kilometers per hour. And once he hit the barrier, the car turned instantly into a fireball. And a lot of the teams within the Formula One were worried about Roma. And while watching the episode, even the people that spent years and years in the Formula One and are aware of all the security measures that are there were worried that if Roma managed to get alive, that will be a miracle. And by our norm, for the normal people, this is actually basically a death sentence. But guess what? Roma managed to get out of the car, out of the fireball, on his feet, sane and safe. And this got me thinking, what would happen if we started design our architecture in the same way the Formula One folks designed their car? What would happen if we started design our systems, our architecture, with the same level of devotion that the Formula One folks are doing to design their car, keeping both speed and safety of the drivers at all times going hand in hand without compromising for speed and without compromising for the safety of the drivers. Now, while watching basically the documentary, I noticed that they kept using the term safety and little mention of security. So I'm not a native English speaker, and I use them basically interchangeably. For me, they mean basically the same. So I opened the dictionary and found that security means the state of being free from danger or threat. Now, from a security perspective, and the software engineering world, we know that this is actually not true. We know that when we put a software facing the internet, there are a lot of things that can go wrong. There are a lot of hundreds of malicious users that try to sneak in onto your system and break your system into its knees. There are a lot of things that can go wrong. So once we put our application facing the internet, it is no longer free from danger or threat. When I look at for safety, however, it means that the condition of being protected from danger, risk, or injury. And this is exactly what we're trying to achieve in the software engineering world through our security practices, right? We know that there are a lot of things that can go wrong. The internet is not a safe place. The environment that our application is running in is not safe. And we're trying to protect the application and the data of our users by having a lot of security practices in order to do so. And that actually means good architecture should let us go as fast as possible in a safe manner. Now, I'm not going to change the name to DevSecOps because like DevSecOps is bad by itself, but just to keep that safety is what we care about and not actually security. So throughout this journey, throughout my research in understanding like the Formula One folks, I started a comparison between what the FIA and what the Formula One folks do in order to improve the security and the safety of the drivers. And what are the patterns? What are the things that we can learn from that and implement in our architecture, in our softwares, in order to make it more secure and safe? And I ended up having 10 measures. 5 of them are what we call pre-crash measures, the thing that we do before the crash to make sure the environment is safe, and 5 of them the Formula One and the FIA does in order to ensure that the driver, if the accident happened, to rescue him as soon and as fast as possible. And I wanted first to make sure that the data or the regulation that the Formula One introduces and the FIA, which is basically, so the FIA is the organization that oversees the Formula One and regulate the motorsport of the Formula One. I wanted to make sure that basically what they introduced and what they try to enforce is actually working. And it does actually work based on the data. So this graph highlights the number of deaths per year. And as you can see, the more we introduce it, the more regulation we introduce, the more less accidents we have and the more less deaths we have in the sport to make the Formula One a safe sport. And the last death happened in 2014, basically. And the second graph shows the number of days between fatal incidents. And if you compare with the last graph, you see the more we introduced regulations, the more regulation we introduced, the larger the number of days between fatal incidents, which highlights that whatever Formula One are doing are basically working in order to make the sport more or less dangerous. But it's still dangerous by a lot of factors. Yeah. So starting with the first five, which I call the pre-crash measures, and those are basically the things that the Formula One and the FIA ensures before the crash to prevent the crash, basically. And even if the crash happens, we ensure the safety environment that happens, and see if there are any analogies that we can get from the software engineering world. And the first one is the seat belt that the Formula One people have in the car is different than the one we have in our normal cars, which in the sense that it has a 6-point harness, and it looks like this. So it has a 6-point harness. The driver can't uh, fasten the seatbelt on his own. He basically needs the support of the team and the pit crew in order to fasten his seatbelt. But uh, if he wants to release it, he just needs to press a button and boom, it is released. And this is actually similar to push to deploy or push to release analogy, right? And this is actually achieved through the adoption of automation. Automation is really important in the software engineering world for a lot of reasons. The first one is automation can enable the teams to deliver greater value by eliminating the manual efforts. Whatever it takes time from the team, whatever the team does basically take or eats from their time, from the manual work. So if we can automate things, that means more time goes back to our team and they can pursue more productive and innovative pursuits in their day-to-day work. Automation can also decrease the number of errors that occur from the manual approach. We as humans sucks in terms of manual things. The more we do things, the more we get bored and the more that can lead to errors. So machines excels at that, doesn't get bored, and delegating that to them would help to avoid human errors. And automation can also increase transparency in the end-to-end development cycle, which is important for teams to identify when and how certain actions were taken to fix a vulnerability or a change or make any other improvement into the code, basically. So transparency can also be increased by having automation where everything is basically transparent within the team. So that was the first one. The second one is stringent dynamic, static, and load tests to ensure the safety of the drivers. And that means that they test the car through different environments and the different conditions that the car will go through in a racing day. That means it is the car in a wet day, it is the car on a hot day, it is the car on a humid day, it is the car in different environments, in different conditions, in different tracks, in order to gain data, analyze the data, and understand how the car basically reacts to these different conditions. And that is, from a software engineer point of view, we should basically expose our artifact, expose our application to the same environment that it's going to be exposed to in production. And we can achieve that by starting to have a trusted, repeatable, and adversarial CI/CD pipeline. And adversarial is important here because we ensure that everyone's voice is heard in shaping the form of our CI/CD pipeline. Developers, operations, and also security, by introducing pieces here and there that checks for security, basically, which is really important to improve the DevSecOps practices that we have and make us increase our velocity, increase our trust, and increase the trust that we have in our application, making sure that most of the checks from a security point of view are done before it reaches basically production. Another thing we can do in order to ensure that we are exposing our application to the same environment is going to be exposed to is canary deployment. And canary deployment are a practice within software engineering, which is a pattern for rolling out releases to a subset of users or servers. And the idea simply here is to first deploy the change to a small subset of servers or users. And in the example here, I said 1%, but that depends on each configuration and each business. And then roll the change to the rest of the servers when we are confident about that release is not actually exposing any issues, both functionality and security, and from a feature point of view. So we start by rolling a subset of traffic of new release to the users. We check the analysis. We have metrics that automatically gauge how good/bad this new release is, and then if it's good, roll it out to all the users. If it's bad, roll back and try to fix it, which gives us an understanding of how our application and artifact behave in production, and also will help us gain confidence over our release process. The third thing they have is the cockpit is surrounded by deformable crash protection structures. And this is actually the cockpit. So this is actually similar to designing for failure in the software engineer for world, right? So they build the car around this structure, which is the cockpit, which whole purpose and sole purpose in existence is to protect the driver safety, and they test the cockpit all the time basically. And that means in a software engineering world that we should design our application basically for failure. Design for failure necessitates basically thinking about fault tolerance at all layers. No longer application and developers should confine themselves to thinking about functionality only. We, as developers, must also consider the question of how to design that functionality in face of database issues, network issues, congestion, full deployments, and a lot of things. Another thing we can do in order to improve the resiliency of our application is basically mutual TLS. And mutual TLS, in short, MTLS, we call it, define the secure trusted communication when both parties and are verified. It is basically an extension of TLS, which is HTTPS, that we all know about. So MTLS is both the client and the server are exchanging data. So they are both servers and both clients. So we need to exchange the data and make sure that both the client and the service must mutually be trustworthy before sending the data and starting exchanging the data. When MTLS is used, both identities are verified and validated, as I mentioned. So the data and payloads that are circulating inside this cluster are encrypted, which is a great win from a security point of view. A third thing we can do is design our application in a micro-segmented way. And micro-segmentation basically guarantees that sensitive data are never exposed to the internet. So if an attacker manages to extract some data or compromise some internet-facing system, this structure or this architecture deforms itself, and the attacker will not have access to the final data. So it means that we're putting our data in the data and the service access the data inside and put them as far away as possible from the internet-facing systems. And the internet-facing systems are basically proxies forwarding the data and shaping it in order it gets out. And that's basically like designing crash protection structure. So you can basically, in a micro-segmented architecture, you can compromise the outer layers without impacting the driver, which is the user data and in our end. Okay, moving on. The fourth thing in a pre-crash measures are before they race, driver must demonstrate they can get out of the car within 5 seconds. And they do this before every race. So the drivers must demonstrate that they can get out of the car within 5 seconds. If they can't do so, they are basically kicked out. They can't race for a day. This is effectively not designing for the worst case, but this is actually testing for the worst case. What happens when you crash? What happens when there is a crash? I want the driver to get out of the car as fast as possible. So show me before you have the crash. That's basically the whole idea. And this is similar in software engineering to the chaos engineering pattern. So chaos engineering is a discipline to identify failures before they became outages. And we do that by proactively testing how the system and how the architecture responds under stress. By doing that, we can identify and fix failure before they become outages, and we end up in the news basically. And chaos engineering help us also to identify what we call the unknown unknowns. In our system, we all have things that we know our application. We all know that if something bad happened, this is how our application will react more of the case. But what chaos engineering help us to understand is the things that we don't know. We don't know about application, which is the most worrying thing, and that would what cause basically most outages in the application. And you can start small basically and grow gradually. You can design the smallest hypothesis and the smallest test possible, basically start introducing delays in your application and see how your application will react in terms of delays. Then measure that, the impact, assess the failures, look for sign of success or failures. And when the experiment is over, you would have a better understanding of how your system react in those scenarios, and you can implement fixes, and then you can grow gradually and add in more tests and more things to assess. And the final thing in the pre-crash measures is constant monitoring and replacement of the tires. Now look at this. Notice how the Red Bull team trying to not to replace the tire, not to fix the tire, but actually change the tire. And this is the world record of changing the tire. It's 1 second, 82 milliseconds. And they are not proud of taking 2 minutes. Oh, sorry. They are not proud of taking 2 minutes or 2 hours off or 2 years, but they're proud of taking less than 2 minutes. Compare that to the attitude that we have while treating our service or servers, while keeping them for months or even years without replacing them, keeping them alive, trying to patch them and keep them up and running as long as possible. Now, we're all aware of the pits versus cattle analogy, which means basically with the rise of cloud infrastructure, we should treat our infrastructure as a disposable entity. Like we should spin them up at will whenever we need them and throw them away whenever we need them. Now, what happens if we push this a little bit further to the chickens analogy? And when we do that, other metrics comes to mind, becomes relevant to discuss, such as the reverse uptime. And to explain the reverse uptime, I'm going to start with an example. So imagine that you have configured and secured a production cluster. And in this cluster, you're running a few mission critical applications for your company. Sorry. And then a hacker or an attacker managed to find a security hole in your software stack and has gained or access to one of your cluster nodes. This is by itself is bad, right? But even worse, the attacker or the hacker managed to mask his presence on this node and gain access to the root node. And they use this node to attack other nodes and attack the internet basically, or do some Bitcoin mining, right? Now, what happens if our nodes are constantly replaced? Now, think about it. The attacker is hiding himself, you're not aware. And then there is, after some time, you are basically replacing this the node, killing it up, removing it, and provisioning a fresh one. The attacker will basically lose his base. And the problem is eliminated, at least temporarily, and he will need to do the same process again to gain access. Whatever data he do, whatever metrics, whatever tricks he can to do, whatever data he's saving is gone. So from a security point of view, we can't backdoor a system that is constantly being revised. So from a security point of view, again, reverse uptime helps to track security of my system. So this is actually a great alignment between security teams and operations teams of not only security, but stability of our distributed systems. And combine that with the base image freshness, which basically means when was the last time that you updated your golden image, that you patched it for vulnerabilities present in your base image. And if you have any vulnerability issue with your base image, let's say a Linux kernel 0-day vulnerability, right? And you need to patch that. You know that the maximum amount of time it's going to take to patch your base image freshness is the amount of the reverse uptime before the fix is distributed across the whole fleet, which is a great win, again, from a security point of view. So those are some of the things that we can adopt from the pre-crash measures. Now, moving to the post-crash measures, and I probably need to hurry up because I'm running out of time. I still have 13 minutes. So bear with me here. I'm going to be speedy as the Formula One example in these sessions. So the first one we have is driver can be extricated from the car by lifting out the entire seat. Compare that. So if the crash happened, the drivers, and we can't get the driver out of the car, we basically lift out the entire seat with the driver, get them out of the crash scene and put them away and give them any help or need necessary. And this is similar to designing in a modular way. They basically designed the car in a modular way that enables them to pull the driver out from the crash scene. And our architecture should be designed in a similar way, in a modular way, enable us to pull the trigger as fast as we can when something happens. When an SSH is leaked basically on the internet or someone leaked it, how fast we can react to that and replace it. When a certificate is leaked on the internet, how fast we can replace it. When our user's password database is leaked, how fast we can regenerate that. So designing a system in a modular way would help us to lift the data, or save the data even if damaged environment. And the rule of thumb here, the most coupled your system is, the most likely you will be slow to intervene if something happened, just like the car analogy as I mentioned. The second thing, and there are a lot of benefits of loosely coupled systems. First thing, they have fewer dependencies. So systems, they do one thing, they do it well, and they delegate other things to other systems within your application. And they have fewer failure isolation. If one system of one module fails, it doesn't mean that the whole application failed. It means simply this whole module is failed, and with some resiliency pattern, we can isolate that and keep the application up and running. And loosely coupled systems are easy to evolve from an architecture point of view. Basically mean the architecture is modular, and whenever we need another functionality, we plug it into this modular architecture, which enable us to evolve our architecture in the long run. The second thing they have is a HANS system, and HANS stands for hand and neck system, or head and neck system basically. And HANS absorbs and redistributes forces that would otherwise hit the driver's skull and neck muscles. Let me get a sip of coffee first. And this is basically the HAN system, which basically means when the driver, if a crash happens, since the car is going at a lightning speed, the force that would be generated from the crash are immense, and the hand system would help the driver to absorb those forces and redistribute those forces through his body that would otherwise would basically hit his head and neck. And from a software engineering point of view, this is similar to elastic architecture. And in elastic architecture, there are a couple of patterns that we can implement, starting with the load balancers. If you are having a good day and there's an increase in traffic, then having load balancer would help to evenly distribute traffic across your whole nodes. Having autoscalers, if the traffic increases and your nodes couldn't keep up with traffic, having some metrics or having some thresholds when you can spin up some nodes automatically and handle the exceed additional traffic. Request time threshold, if a service or node is behaving slowly, have some defined threshold. So you free up resources, CPU, and keep your application basically running. In most of the cases, having a degraded performance is better than having no application at all. So depending on the business, so having a subset of the application up and running, probably the premium users, probably a subset of the application is better than having no or being a global outage. And implementing some anti-overload patterns helps to keep your application resilient, such as circuit breaking and exponential backoff in case you're having a bad day. And driver suits are fire resistant, and the suits that the drivers wear are basically fire resistance, which keeps the driver body under 40 degrees even in the extreme heat. And this is how the first example I gave, Roma managed to get out in the extreme heat, because the suit helped his body temperature to stay under 40 degrees even if he was in the fireball basically. And this is similar to keeping the attacker in, trying to limit the damage that the driver or the attacker can bring to our application. And for that, there are a couple of patterns that we can do, starting with having following the least privilege principle, meaning that we give our application minimum set of access rights and resources for it to perform its function. Defensive depth also means building series of defensive mechanisms that are layered in order to protect valuable data and valuable information, and having zero trust. And that means eliminating implicit trust and continuously validating every stage of the interaction of services, of users, of basically everything. Another thing we can do is having hardware security modules, and that's basically whenever we need to encrypt the data, for example, the password, you would require a key from that hardware security module to encrypt the data, and that means that the data, even if it gets out of your database, it would become meaningless, because to decrypt it or to check it, you would need always that key from the hardware security module, which is only available in your data center. So the attacker, if he managed to get the data out, he can't brute force it and make it clear basically and get the data. And the other thing, and probably that's the final thing, is fire suppression system that can be activated. No, that's not the final, but yeah, before the final. Fire suppression system that can be activated by the driver externally or by the race marshal. And that's basically the fire suppression system is, if there's a fire, we'll basically pull the trigger and the car will try to cool itself. And notice how the distributed access depending on the use case. If the crash happened, the driver is awake, he can pull the trigger by himself. If the crash happens, the driver passed out, then the rescue team can press a button to trigger the system. If the crash happened, the car passed out, the drivers cannot get into the car, the rescue team, then the marshal can activate it remotely, which is a great example of distributed access. And that is something we need also to care about in our architecture and our software. There are a lot of policies in order to distribute access, both for users, internal users, and external, and also services, such as communication policies that can be implemented in order, fine-tuned in order to and not be overly optimistic and give access to people that don't need it, and be severely pessimistic and lock yourself out of the door. So it's a question basically of trade-off. And finally, Formula One people are crazy about data. They record basically everything. For each race, there is more than 1 terabyte for each car that is circulating, uh, that is gathered around the car, which is basically a test data. 1 terabyte in one race. That is crazy per car. It's really crazy. And needless to say that no system should go to production without having monitoring tools in place, and also security alerting tools that detect unusual behavior and trigger alerts, enable us to perform whatever measure necessary in order to save our data. And this is how the drivers are in the car. Look how uncomfortable the position is, but that enable them to have optimal position from an aerodynamic point of view. So it's a question of balance basically between security and also speed. And that's to say that it's a question of trade-off as well for design our system between feature and functionality and security. So we need to keep that trade-off in mind. I want to end this presentation with a scary number. In the report of cost of data breach by IBM Security, they mentioned that in 2022, the average business cost of cyber attack is a little bit less than 4 million, but it takes more than 270 days to detect a data breach, which is just crazy. So I hope through this presentation, we get some patterns, some insights on how we can build our system fast while keeping the security and safety of the data and our system in mind. And that's it. Thank you very much. And I'm ready to take your questions.
Thank you, Mohammed. What a wonderful session it was. I hope you all find this session very insightful. We love the presentation and the energy. I think it's not every day that we get to tune into a session that is relatable to everyone. Let's take out some questions. So it will start showing on the screen.
Okay.
Here's the first one.
Can you list some backend testing practices that Spotify follows to ship quality code faster? We do basically a lot of testing, that's for sure. So there is we probably all know the pyramid of testing. So we follow it: test unit tests, integration tests, and also end-to-end tests, depending on some scenarios. Containers really help, and one of the frameworks I want to highlight is Test Container. It's basically it takes the integration checks to the next level. To basically just spin up containers, databases, services, whatever you need to perform the integration test of your application. So have a look at Test Container. Is a really good framework. But yeah, I think we follow the pyramid test as everyone in the industry basically, and we use Test Containers extensively.
Got it. Great. That's great. Here is, I guess, I've got another good question. So let me on the stage.
Please.
So yeah. So as you can see, how we can make security testing easy for a functional QA, as most of the industry that security testing is done by only the experts only. Like every company needs.
That's a real struggle, and unless there is, I would say, upper management commitment, it's to be honest, it's going to be hard. So you need to get some buy-in first, and as I mentioned, the entry point would be at least to start having the pipeline that you use to build and ship your application, having more security tools, and instead of security being the end that you do, start introducing it bit by bit into your pipeline, into your development processes, like once a PR is starting, have a security analysis of vulnerabilities,
Yeah.
dependencies, patterns of coding that would help you basically to help even to onboard even the developers and build that mindset of security. Also, security in uh, having an instance that do basically dynamic or dash testing, which is really good to assert from a security point of view the application and then assessing the production environment. So it would need buy-in, it would need onboarding other people. It's not easy, but it's there are some bits here and there and small wins that you can start with,
Yeah.
mainly by onboarding other teams and other disciplines here and there.
Yeah. Security is like you have to apply at the every layer. Like it could be like
Exactly.
development, QA, and then deployment. Yeah,
Indeed.
that's
Indeed.
yeah, that's great. I've got another one like that is very interesting. So, how frequently are releases done at the Spotify? Like, can you share some insights how into the CI/CD pipeline? Because that is directly like how like how we can manage the quality versus speed, right?
Yeah. Again, I briefly touched upon it. Is automation.
Yeah,
Mainly, a lot of things within Spotify are automated from the moment you push the PR until it's deployed.
yeah.
It's little to no human interaction there. Everything is automated, and I don't have a number, but we
Mhm.
release it a lot. I mean, we release a lot. More than, yeah, there are a lot of releases per day. I mean, even per hour there are a lot of releases going on because like
So,
some distributed system microservices, a lot of teams, so each team is releasing, so at some point probably every minute there is a release happening.
oh, that's clear. Like, what kind of the release pattern that you follow? Like, Canary one or is like what kind of GitHub structure you follow?
What it's can you repeat the question?
So what kind of release deployment do you follow? Like it could be like the candy deployment, or how do you deploy like on the production, the
Yeah,
complete traffic, or it's like the 50% or 50 or something like that.
definitely canary deployment as well. Do have metrics that as I mentioned, metrics that check the release, and if there are any issues, we roll back. If everything is fine, thumbs up, we pull it forward, or deploy it basically. And before that, a lot of testing happens. If a test fail, then we roll back. Yeah. So yeah, automation every step of the way, and the canary deployment to make sure that that is safe. And also in production systems, we have automatic alerts if one of the indicator went wrong, errors, latency, and so on and so forth.
Got it. That's great. Okay. So here is another one that as open source is currently the new go-to solution for the quick fix, right? So what are the some of the best open source testing tool that can be easily integrated and can help developers to test their code base?
Oh, I mean, I'm a Java developer. I use Java a lot. So in the Java world, there are a lot of testing frameworks,
Yeah.
starting from JUnit, Spoke. There are a lot of, I don't want to forget anyone, but there are a lot of testing framework, both in each step of the way. Even the now the framework Spring, Quarkus, Macronaut, Hadelion, all have basically support for a lot of like a lot of testing frameworks that can you up and running after the box. For integration tests, as I mentioned, I like tester containers. It's a great project. One of the best solution that comes out from the container world. So for integration testing, I would definitely use test containers for any language, basically.
Okay. Great. Yeah. As you know that like everyone is trying to like integrate the application, the software is the AI, right? So how AI can bring into software in that automation testing?
Um, I'm 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 really optimistic about the usage of AI in increasing
Yeah.
developer productivity. I've tested Copilot. It's really good.
Okay,
I mean,
that's
it
good.
has its drawback, but it's
Yeah.
really good in a lot of use cases. I think in the as an industry there are a lot of companies that are trying to see how they can fit AI in their ecosystem. Now, Google, for the Google Cloud, they announced that they have their Do It AI, which is basically kind of Copilot, but for Google Cloud, to help you to write for Google Cloud ecosystem, whatever code you would need, and set up the, for example, PubSub or whatever. Um, I think we're gonna soon see more of the testing automated based on AI at some point. Um, Copilot can do that to some extent, but um, still, as we train it to more code, to more testing code, probably we're gonna only write the functionality, and the AI will
Yeah,
take care of the rest, at least
correct.
for the unit testing, probably the
Yeah.
integration testing as well. So that I think I'm really optimistic about that. We'll still need to wait a little bit in order to get there, but we're gonna probably get there soon.
Great, great, Mohammed. Like it was great session, and it was great that you answered all of the questions. So I guess that's great. We can wrap up.
Yeah, and like I didn't have the chance to answer all the questions, but for anyone who wants to have any question, please feel free to reach out to LinkedIn or Twitter. My Twitter handle is laytune, I believe. So that's it.
Yeah,
I
cool.
put it in it.
That's great. Happy testing. Have a great day, everyone. Thank you.
Thank you.
Thanks, everyone.